The Flash, Millennium Falcons, Superman, and the Starship Enterprise. These things have two things in common. First, they are all fictional characters. Second, they can travel at the speed of light. But in reality, can we actually reach the speed of light? But first, we need to understand what is mass and energy equivalence. It's a theory of special relativity that shows the increase of mass comes from the energy of motion divided by the speed of light squared, or as we know, E equal to mc squared. But how did they come up with this? Okay, bear with me. So imagine that you were floating around in space, and suddenly you emit light. Light carries away some energy, but due to the law of conservation of energy, you will receive the same amount of energy. Then I send myself to space with a spaceship and trying to get to you. So in my perspective, I will see you moving past the window while I'm standing still. So I can assume that you have some kinetic energy with you, and due to the emitting of light, you will lose some energy as well. The special relativity tells us that we would experience time differently according to velocity. So we will measure the different values of frequency, thus the energy of the light. This is called the Doppler effect. So the light energy is not going to be E anymore due to the Doppler effect. Instead, it's going to be E times 1 plus V squares divided by 2C squares. So to recap, if I travel past you, I will see you moving. Therefore, I can assume you have kinetic energy. And due to the Doppler effect, the energy lost from the light is going to be E times 1 plus V squares divided by 2C squares. But if I wait for you to emit light, you will see that the energy loss is now E, and then the spaceship moves, therefore you will have some kinetic energy. We know that the total energy of both of them are the same, so the equation is going to be Ke1 minus E times 1 plus V squared divided by 2C squares equal to Ke2 minus E. Then we arrange it. It will give us E times V squared divided by 2C squared plus Ke1 equal to Ke2. We know that the kinetic energy is equal to half of mv squares. Therefore, we can put that in the equation. We also know that Ke1 is not equal to Ke2. We know that the velocity of the object doesn't change, so what we can change is the mass of the object. And by cancelling, we're left with E divided by C squared is equal to m2 minus m1, or it can be written as E equal to mc squares. But that is not all. E equal to mc squares only describe an object that have mass but aren't moving. The full equation is E squared is equal to mc squared squares plus pc squares. Are you confused? Here, I make it easier for you. So first, you need to draw a right angle triangle, and then put the label on the side of the triangle. By using the Pythagorean theorems, it will give us E squared equal to PC squares plus MC squared squares. In fact, the closer the energy side is to the PC side, the closer that something is to behaving like a light. So an object velocity equal to C times PC over E. As the ratio getting closer to being 1, therefore the speed is getting closer to the light speed. For a substance with mass, the energy and the momentum of the object is never going to be the same. Or as I can say, the ratio is never going to be 1. This is because the hypotenuse of the right angle triangle will always be longer than its leg. So in conclusion, it doesn't matter how small the mass is or how high the momentums are. But if there is mass, it will never reach the speed of light. Therefore, light always be the fastest.